right, just going on here, just a couple things. First of all, that anagram program, I don't know if I ran that, so. And what was it? It was mattress. And I don't remember what the other word was. Smartest. They are anagrams, and the other one was dumbest and stumble. And they're not anagrams, so it appears at least to work. All right. So close that, and I want to go over 3 different examples. You all know what a palindrome is, right? You know, same forward and backward. Now, this was taken out of a book. I went back and wrote it, but this was taken out of a book. They asked you to write this program three ways. All right. It says here, ignore all characters that are not letters. Use integer variables to keep track of the array position. So that was the first one you were supposed to do. Okay. Then they asked for part B to rewrite it, use pointers instead of integers to keep track of the position in the array. So remember, when we talk about a pointer, all right, we're talking about a memory address. And then third, remember the fact that you can use an array name as a pointer. So these programs will all work identically to one another, but syntactically, they'll all look a little bit different. All right, so again, the first one, ignore all characters. What you're going to see is when we look at the second one, it's got the same comments, but it says that's this one. When we look at the third one, it goes down to C, and it says that's that one. Does that make sense? So it's written 3 times. All right, so here's the first one. All right, so we just created a pound-defined constant called length. So the maximum length we're expecting you to type in is 80 characters. Okay? Why? Because 80 characters has always been symbolic kind of the size of a line of text. All right, it had to do back in the old days when you were printing on those big green matrix printers, and you needed to have a little margin on the left and a little margin on the right, and it was about 80 characters you could put in there. So, all right, so we're coming in here, and we've got a character array called message that's of size 80. Then we also have a single character, and we have a couple of integers. Then we tell it to enter a message. So again, as always, let's play computer here. So CL palindrome A.C. Cannot open it. So because I wrote palindrome, not palindrome. All right, there it is. So palindrome A. All right, and I know, for example, race car is the same forward and backwards. I don't know how I know that. I don't really care, but boom. All right, so it is a palindrome. Now you'll notice if I run this again, whoops. Well, when you run it, you've got to run the file. So R, hit the space bar a few times, A, C, E, all right, C, A, R. It is a palindrome. So it's throwing away all the junk in between. Does that make sense? Well, either I'm lowering it or uppercasing it. Yeah. So in other words, we're setting this up so that it'll handle. All right. In fact, I believe it even handles. I could be wrong. I'll take your question in a second. Race. All right. So it didn't have any problem with numbers either. I think you can put in special characters and all that good stuff. Yes. Okay. So let's take a look. It's not a long program. All right. You say, well, 70 lines. Yeah, but look, the first 25 are comments, and the next 5 are either 5 or 6 or whatever. So it's about 40 lines long. All right. So we're told to enter a message. As long as the message is less than 80. All right, so we're not guaranteeing this is going to work if something is over 80. And I'll get a reason for doing stuff like that too. And we could have made it bigger than 80. Could have made it 256, which is a common size for a buffer, which is what this is. But if you don't put anything in there, people are going to think they can just keep typing. You know, we're talking pages and pages worth of stuff, and that's ridiculous. All right, so again, as we talked about before, we're going through it a character at a time. right? All we're doing right there is we're checking to see if it's a \n. The \n, when we hit enter, that's signifying that we're done with our input. Okay. Then, as we're going through here, okay, so we have, while n less than length, what's n? Well, that's a number. So we're just counting through here. So we're checking each character as we're working our way through. And as Mike said, we're making it uppercase. All right. Then in English, what we're doing right here is we're saying, okay, break it in two and go from this end and go from this end and keep comparing characters. Does that make sense? And that's all we're doing. But the point is, even if you say I don't really understand what you're doing, what you all should understand looking at this is there's nothing special as far as there's an array and there are variables. But there's nothing else that's special, so to speak, in here for this. All right? As opposed to the second one where it says, now, as you can see here in the gray, write a revised program that uses pointers instead of integers to keep track of the positions in the array. So now we've got a character pointer, and Q, bless you, is pointing to the beginning of the array. But other than that, it looks very similar, except now what are we adding to? Well, we have to add, since that's a pointer, we have to use it with star Q. Now, my guess is this is such a short program that if you looked at this and you looked at the tests in here, etc., and you ran the whole thing because it's basically the same program, and you hooked it up to the system clock, there's going to be almost no difference. All right? Does that make sense to people? Because it's not a big program. But when you're talking about programs like I worked in at AT&T, there were pointers up the wazoo. Because again, I've mentioned this to you before, the average person back in the days of rotary phones picked up a phone. They didn't have dial tone in 3 seconds. They put it down again. So conceivably, the phone company was losing money. That was always the first check we had to make. Literally, every time we put in code. Do you still get dial tone in 3 seconds? The second one, you were supposed to actually do, these phones we had in here were indestructible. And we had regular, not a floor with a carpeting, we had concrete floors. We were supposed to drop the phones. Not throw them down, but drop them from about as high as we were to the ground. And then you were supposed to hang it back up, pick it up again, and make sure you still got dial tone. Those were tests that we did. It sounds stupid, but those were tests that we had to do. All right. Well, I saw a guy, I was at the Janesville Mall over the weekend, and a guy next to me dropped his cell phone. And I was amazed at all the pieces that came out. The back came off. The battery came out that was in it. There looked like it was a little chip. That came out. And the funnier part was watching him try to put it back together again. All right? Because I don't think he had a clue. I wasn't going to say that I could or couldn't do it. None of my business. All right? So notice that when we're working with the values, we've got star P and star Q. All right? And when we're all done and we filled it up, then we don't need the P and the Q. Because this is working with it a character at a time. That's working with the entire thing. But again, notice if we run this one. It's very similar to the last program, all right? Still a palindrome. All right? So what I'm saying is take a look at this. It's not going to make a lot of sense now. It may not even make a lot of sense when you look at it, but take a look at it between now and Wednesday. And if you have questions, please come to class with them. What I tried to show you here are 3 ways of achieving the same goal. One that used just arrays. All right, that was the first one that we looked at. The second one here, as it says, use pointers instead of integers. So the first one, where we're here, we are using star P, for example. In the first one, what did we do? We were using this. All right. And the last one, as it says, write another version that's used to take advantage of the fact that an array name can be used as a pointer. All right. So again, as you work your way through it, much of it will look the same as what we did last time. But the way that you are accessing stuff when you're in the loop will look a little bit different. And again, the idea was to show you this. Now, if there's good news on this, if there's good news, what I'm about to tell you, it's going to be good news, yet it's going to be bad news. All right? The good news is, really, pointers are easier to use in Objective-C than they are in C. That's the good news. Well, that's fine. What's the bad news? Bad news is virtually everything in Objective-C is a pointer. Just about everything that you do is a pointer. All right? So that's why the syntax will look funky. But once you like, oh, that sort of makes sense, then you do it this way, and then you do it this way, and you're not going to be doing this a bunch of different ways. But remember, I put that circle on the board a while back, and I wrote in there, I put another circle in it. In the middle circle, I wrote C, and on the outer circle, I wrote Objective-C, because it's a superset, which says that I can still write code like this in Objective-C if I want to. I don't see any advantage of doing that, but if you wanted to do it, you could do it. Right. Yes? Yes. Because what message is, what you're doing by doing this is you're doing the same thing as this. That's what you're doing. Yeah, well, let's see. That shouldn't break anything, but if we'll find out real quick whether or not it does. So I saved it. I'm going to run it again. All right. Oops. No, that's a really good question that Zane asked. He said that the author doesn't exactly do it the way I'm showing you. The author, Koshin, has his own style, all right? But if you would sit there, I'm not doing this, but let's say that on your first assignment, one of the things I did was I said, now, find yet another way to write this. You could all do it. Yeah. No, I'm really not. It's just my take on it. I don't see the need to do that. You can, but what you're doing is you're setting it equal to the array, which automatically sets it equal to a pointer to the 0th element of the array. And I think I mentioned this last time, not to belabor it too much, but again, if I pass this, if I pass that entire array to a function, the system literally does pass it as the address to the 0th element. It literally does that. Right. But that's arrays of any type. All right. So, we went through the anagram one. We went through all the palindrome ones, including C. So this is what's left. This one I put in there just so you could start seeing some of the stuff. I found this in a book. I'm not going to make claim to this at all, okay? And write a C poker program. Next, modify it. Well, you look at it, there's a lot of stuff in here, but just to show you, because this one has just arrays. There's no pointers in here. And then I thought, well, it'd be kind of cool to have you redo this one using pointers. And I thought, well, then you might pull your hair out and then look like me. So I thought you probably wouldn't want to do that. So if I run this one, it's a little hard because I really should have given some instructions on how to do it. Okay. First of all, it keeps running, just so you know. You have to literally, as far as I remember, do a control break to get out. But enter a card. All right. Well, notice if I put in here, it's a bad card. But if I put in this, that's now 4 of spades. Do you understand? So again, looking at scanf when you're working with this stuff. So I want a 4 of spades, I want a 4 of clubs, a 4 of hearts, a jack of spades, and a jack of hearts. And it says you got a full house. So you can put in different hands. I mean, if I come through here and enter a card, and I say 2 of clubs, 3 of spades, 5 of spades, 8 of hearts, and 9 of clubs. Basically says all you got is a high card of a 9. You know, you're probably not going to win if you're playing poker. But there was some stuff that was put in there. I added a little bit more to it, but not much. So it'll recognize a flush and a royal flush, etc. But again, the idea behind this, so I'll do a control break to get out of it, all right, was to show you that even in a program that's not really that complex, if we started on about line 25, notice there's a good 250 lines, 275 lines in there to do all that stuff. So just so you start thinking about the fact, so what are we doing in here? Well, look, in here, we're figuring out all the possibilities. You could have a straight flush, four of a kind, full house, a flush, a straight, etc. There's not even, so there's a straight flush. There's even more for a royal flush, right? That kind of thing. You know, so there's even more than could have been put in this. But you start to see, this is a simple program that runs stuff from a command line. And it doesn't even handle every case. And it's already upwards of 300 lines. So you start to see it doesn't take much before these programs can, to quote Jimmy Carter, all right, if I can go to the Wayback Machine to the 70s, so it starts to proliferate. All right. I don't think I've ever quoted Jimmy Carter, especially in a classroom situation before. So that was interesting anyway, at least for me it was. Here's another one that's sort of similar to that. All right, again, I've tried to tie together. This is one that I took partly out of a book and I didn't like it, so I went back and rewrote it. All right. You come up and you create an array and it generates random numbers. And after it generates the random numbers, it sorts them both in ascending and descending order. And it uses just arrays. Again, should be able to go back and really write this with pointers. So if I run the particular program here, and if I run the program now and I just, whoops, sorry. All right, so I repeat digits. Enter a number. 1, 2, 3, 4, 5, 6, 5. Okay. Pretty obvious what's going on there. All right. I did find out because I just wondered what would happen. So I came in here and I did this. Which isn't a good thing to do because I said I think that it was an integer. So it does what it can. In other words, it didn't blow up, but the answer isn't correct either. All right. And I believe that actually is correct, isn't it? Now, what could we have done if we wanted to? We could have come back with the ASCII values. There's a lot of stuff that we could do with this program if we wanted to. So one of the things I was thinking of putting in there as an assignment was to take one of these existing programs, this one or one of the palindromes, not the, well, you've already got the palindromes, but maybe this one, and have you redo it using pointers. All right, just so you get some practice doing it. All right. See, that was met with a lot of applause and other stuff. So, all right. So the only thing I did want to mention was on this repeat thing, because I really didn't go over this one at all. This is the repeat digits one. I wanted to show you something that was on here. Whoops, sorry. File, open. There it is. All right. Again, when you come through here, all the stuff that's in here should make sense to you. Notice just a couple things. I made the number that you read in a long, so at least you can read in a bigger number. But you still saw when I held down on the 9 how it blew up, right? So what this is doing in here, this is going to fill it. We want to fill the array. And we want to fill it with two things. We want it to basically have how many things are in there, n, the number, and we want a count of all the different digits. But we also want to, so that's calling one function called fill array. Then we've got another function that you should be able to tell when you look at this. Repeated digits has to be a Boolean, right? Because that's a shortcut for repeated digits equal true. All right. So repeated digits better return something of type Boolean. Not print, but wherever repeated digits is in here. All right. All right, it's in here someplace. But you get the idea. And all we're saying in here, if it doesn't return true, there's nothing that was repeated. All right, what does that mean? In English, it means this. If I run the program, No repeated digits. Now, I proved it by showing it, but what we could have done was said just no repeated digits and not printed out anything, right? Because every time that should be, be basically everything is a 1. There's nothing that's repeated. Again, that's proving it right here. There's a 1, 1, 1, 2, 1, 3, etc. But if you want to say there was no repeated digits, I could have had a message that said there are no repeated digits in 1, 2, 3, 4, 5. Just another way that it could have been done. So, all right. And then lastly, because we started looking at it already, again, in here, it's important to realize when you're going through this, selection sort. There are built-in sort routines, but I just took one out of a book and wrote it to sort everything. All right, for sorting those integers. Why? Because it made it easy. So again, sort integers, I think. All right, and again, they're random numbers, so you can see them right there. We run them again. They should be the same numbers. But again, you've already seen that proven to you today that it's going to depend on where you seed the rand, if you seed the rand and where you seed it. All right. If you want something to be truly random, you should be seeding the rand every time that you're going to ask for something random. You should be seeding the rand before that. And even then, there could be patterns, but it's just the way that it worked. All right. Maybe I told you about this. I always remember senior year in high school, met with my counselor, and he said to me, Ned Nimacek, he said, you have to take another math class or you won't graduate. I was stupid enough to tell it to my parents, okay? So they made me take another math class. I thought, well, you screwed up, I didn't. So I took a class called Topics in Math. Great teacher. You know, the guy was like 20 years old. You know, at the time I was a senior, I was 17. All right, but real nice guy. So we spent an entire period flipping coins. Now, we didn't do it with a computer. This was back in the 74 or something, like 73. But you may or may not be aware of this. Supposedly, most pennies, at least at that time, were weighted a little heavier on the head side. So you should get more heads than tails. All right? But the point is, since it was really, truly random, and he didn't want us to catch it even, he wanted it to fall on the table or on our desk. But sometimes you'd get 5 or 6 heads in a row. Sometimes you'd get 5 or 6 tails in a row. It was random. But saying it's random means you can, and you could have a repeating pattern. You could get head, tails, then head, tails. So you still can run this program again, and you can find something very similar. Now, again, if you're going to run this, if you really want to see how good it is, you really should put in the numbers between 1 and 10, or 1 and 25 would probably be better, because, well, what are we printing? 1, 2, 3, 4, 5. You are doing 10 of them. So you do the numbers between 1 and 25. If you're going to do 1 and 10, you should at least make sure the order is coming out different every time, or that it's not constantly repeating type of thing. So again, the idea behind this was to start getting into some of the code in 9, 10, 11, kind of put an ending, so to speak, on the stuff for 1 through 8. So I'm going to go through probably somewhere around a half dozen more programs on Wednesday. And one of them is going to be pretty heavy. It was one I was going to assign to you, but I thought this is too much to expect of you. So we're going to go through a fairly complex program with structures, all right, just so you see it in action. But like I said, I will try to, this weekend, write the assignment, and I'll put it out there. And what I'll do is if I put it out there, I'm going to do 3 things. First, I'm going to email it to each one of you to your Blackhawk account. Second, I'm going to throw it out there on Blackboard anyway. And third, I'm going to throw it out there on the P drive. Some of you look at one of those things and don't look at the other ones. Some of you look at all 3. But at least you can't say, well, I didn't know you had the assignment ready. When it's done, I'll make it available to everybody. But before I make an assignment like this, because this is a more complex assignment, I always make sure I do the programs first. I did that once. I gave people the program. They gave them 3 programs, and one of them I didn't realize wasn't possible. And I literally, you talk about people literally pulling their hair out. I had people coming in, and finally a guy stopped me in the hallway and he said, okay, I've literally spent 9 hours on this program last night. I don't think it's possible. So I put down, I pseudo-coded it, I put it down, and it wasn't possible. And I felt really bad then. I did. I wouldn't want to give you an assignment that you couldn't do. All right. Yeah, you might learn a lot, and he said he did. He really didn't mind. When he first said he didn't mind, I didn't really believe him, the way he said it to me. All right. So I'm going to make sure I do them first. I'm going to shoot for it by Monday, maybe even by the weekend. I don't know. All right. That I have all that stuff out there. All right. Questions? Because I'm done. It's a little early, but I'm done. All right. Because that's all I had. So again, when you do come in here, there'll be another folder out there, just like, you know, but it'll be a week from today is the 3rd, so it'll be 09 dash, and I'll put that out there as soon as I get it done. So you know what? Sometimes you'll find I've got stuff. It's like that day didn't even happen yet because I've already got the stuff done. But it's getting harder and harder to keep ahead. Right? For some reason, my youngest daughter thinks I'm good in science, so I'm doing science with her almost every night now. All that junk that I made it a life's mission to forget.